welcome back. In this session, we will continue our investigation of reactions, only this time with a frame element, that is not a straight beam, and a concentrated moment. Let's see what happens. Okay, so as we mentioned, for this exercise, we're going to look at this framed element. That is, it is not a straight beam. However, when we are looking at reactions, it really does not matter what kind of structure we're looking at. If it's a straight beam, if it's a truss, if it's a multi-story frame. What matters is what are the external forces, what are the supports, and what are the distances. So it can be a blob of jelly for all we care. The main thing is we know the distances. So let's have a look at this structure here. I've got a frame, AB. I've got 2 meters in the X direction. I've got 3 meters in the Y direction. And I can see at this point, let's call it point C, that I've got a concentrated moment of 6 kilonewton meters. According to my sign convention, this is a negative moment, but we'll get to that. So the first thing that I need to do is I need to create my free body diagram. And I do that by putting the reaction forces in place instead of the supports drawn. Let's have a look. At A, we've got a pin support. That means 2 forces. Let's get rid of that support there. Let's draw our reaction of AY and AX. And at B, we've got a roller support. Now note, a roller support only has one reaction force. That reaction force is always perpendicular to the ground. So if this is the line, I need to be perpendicular to that. So let's get rid of that and draw in here my reaction force of Bx. So note here, as a difference to what we've solved before, here we have 2 reaction forces in the X direction and 1 in the Y direction. And that's it, we're ready to solve. I can see that if I do sum of forces in the X direction, let's start off with that, with this being my positive direction, I've got AX plus BX equals 0. There are no external forces in the X direction, so AX equals minus BX. If I look in the Y direction, so sum of forces in Y equals 0, with this being my positive Y, I can see that I've got AY in the Y direction and nothing else. And that means that AY has to be 0. And now for my last equations, I am going to do moments. Let's choose to do moments around A, just because there are 2 forces at A. And when I do moments at a point, anything that passes through that point does not contribute to moment because there's no distance. Moments around A, I've got Bx, right, contributing a positive moment. So let's just look at the line of action. So this is the line of action of Bx, right? And it has to return to point A. So we need to go in this direction, and we can see that is anti-clockwise, therefore a positive moment. The distance, since Bx is in the X direction, the distance is the perpendicular distance, therefore the distance is the distance in Y, which is 3 meters. Let's start off by writing down that. So plus Bx times 3 meters. The only other thing we have here is that concentrated moment of 6. We already said that it was negative, and it's already a moment, so we don't need to multiply it by anything. And that's all we have here. So that equals 0. Quick sense check. Here we have Bx times 3. That is a force, so Bx will be in kilonewtons times 3 meters. That'll be kilonewton meters. And 6 is already kilonewton meters because we know that in one equation we have to have the same units. So following on from that, 3Bx equals 6, and therefore if we divide both sides by 3, Bx equals 2 kilonewtons. Okay, and I just want to kind of talk about units here. This is kilonewton times meters. This is 3 meters times kilonewtons. So if I've divided by the 3 meters, I'm left here with kilonewtons. And that's it. The only thing we have left to do is go back to our first equation, and we know that AX equals minus BX, and therefore AX equals minus 2 kilonewtons. And the only thing we have left is to write these back into our diagram. So starting off with AY, that was 0, so I can just get rid of that. AX worked out as minus 2 kilonewton. The minus means that I assumed a certain direction. You can see I assumed an arrow going to the right. In fact, the minus tells us that I assumed incorrectly. Therefore, I need to get rid of this and draw it in the correct direction, which means going this way with a magnitude of 2 kilonewtons. And the last thing was Bx, which worked out as plus 2 kilonewtons, and therefore instead of Bx, I just need to add 2 kilonewtons here. So just now we've seen how to solve reactions where we don't have a straight line beam, and also when we don't have point nodes, we've got a concentrated moment. As we saw, we still follow the same three equations: sum of forces in x, sum of forces in y, and sum of moments at a certain point. We can also do a little check. Let's quickly do that now. Especially in the beginning, when looking at reactions, it is important to check ourselves. Let's quickly do a check. Now the check I'm going to do is going to be sum of moments at the point we didn't do. So sum of moments at B, with this being my positive moment direction. Now I'm assuming that this will be 0 if I've solved correctly. So let's see what we've got at B. The 2 kilonewtons at B pass through B, therefore do not contribute to the moment. We've got a negative moment of 6, that's the concentrated moment, and we've also got a positive moment from this 2, creating a moment in this direction, which is anti-clockwise or counterclockwise, which is positive in our sign convention. So plus 2, that's the force, times a distance of 3 equals 0, and we can see that that indeed equals 0, and therefore the check is complete. So we've solved the reactions in a frame with a concentrated moment, and we've also done a check to make sure that what we calculated is correct. And that's it. As you've seen, it doesn't matter if it's a frame or a beam. The main thing is knowing what reaction forces to draw at the supports, what the external loads are, and what the distances are, and just following through on those three equations of equilibrium in 2D. And that's it for now. Thanks for joining me. Bye for now.